Hello friends, in this video we are going to discuss the previous year GATE question number 50. This question is from GATE 2009 exam. So let us read the question. The circuit shows an ideal diode connected to a pure inductor and is connected to a purely sinusoidal 50 Hz voltage source. Okay, it is a 50 Hz voltage source we are having. Under ideal condition, the current waveform to the inductor will look like. Okay, so here we need to find the I0 waveform, and they have given the four options for the I0 waveform: A, B, C, and D. Okay, so here we are having the circuit. It consists of only inductor, so it is like a load is a purely inductive. Okay, so as we know, when the load consists of inductor, load is purely inductive, then whatever the energy stored by the inductor, the energy will be taking the same time to release the energy. Okay, so time taken by the inductor to store the energy is equal to time taken by the inductor to release it. Okay, so this is the case, right? So here if you check from omega t is equal to 0 to pi, Vs is positive, so diode will be in the conduction mode, inductor go on storing the energy, so I0 will be flowing in the clockwise direction. Okay, so I0 from 0 to pi. Yes, inductor is storing the energy. Inductor is storing the energy from omega t is equal to 0 to pi. Okay, so I0 waveform, it will be like this. From 0 to pi, it will be like this. Okay, next from pi to 2 pi, supply voltage is negative. From pi to 2 pi, it is a minus here, plus here, right? It is like inductor will release the energy, right? So direction of the current will be same. Okay, so diode will be in the conduction mode only, right? So I0 will be like this. Okay, so it is like a inductor stores the energy, and after that inductor releases the energy. So this type of waveform will be having in the I0. After 2 pi 3 till 3 pi, what will happen? Again the inductor stores the energy. From 3 pi to 4 pi, inductor will go on releasing the energy. Okay, so this type of circuit, this type of waveform will be having. Okay, this type of waveform will be having. Is clear? Okay, so here the waveform will be like inductor stores the energy, inductor releases the energy, stores the energy, inductor releases the energy. Okay, so if you check from 0 to 2 pi, it is like a one complete cycle of the supply voltage. Okay, one complete cycle of the supply voltage, but supply is of 50 hertz. Okay, so can we say that this time t is equal to 1 by 50? Yes, so it is equal to 0.02 seconds, is equal to 20 milliseconds. Okay, 20 milliseconds. So if you check, yes, for this one pulse of the current, yes, time required is equal to 20 millisecond. Time required is equal to 20 milliseconds. Okay, so 0 to 20 milliseconds, one complete cycle. So if you check the options, in this case it is showing the, yes, current is inductor current increases, inductor stores the energy, after that it decreases, means inductor releases energy. But what is time? This is like a 5 millisecond. Okay, or the 5 second. Okay, next in the second case if you check, it is like for 10 millisecond they have shown. Okay, in the third case it is a 20 millisecond, and in the fourth case it is like a 10 millisecond. Okay, so whether the time is 10 millisecond, no, the time is 20 millisecond. Okay, so the correct option is option C, right? Here it is a 10 milliseconds, so not correct. Here it is also 10 milliseconds, so not correct. Here it is a like 5 seconds, so it is also not correct. Correct option is option C. Option C is the correct option. Is this clear? Inductor stores the energy, and again inductor releases energy. Stores the energy, releases. Right? So this is about the question number 50. In the next video, we are going to discuss the question number 51. Thank you.